Oh, in this section, I will talk about what is really a chemical reaction, what is really happening in the microscopic point of view. Let's consider one of the example you learned before. For hydrogen gas, if you use a burning spin and then put into the mouth of the test tube and you will hear a pop sound, it's actually a small explosion. And what is really happening is that some hydrogen diatomic molecule they react with the oxygen in the air to form water. And because the reaction rate is very quick, so that some of the gas will come out from the test tube very fast and then make the pop sound. Well, let's consider what is really in between. There are two hydrogen diatomic molecule with some oxygen diatomic molecule. How can you make this hydrogen oxygen to become H2O? What do you need to do to these molecules? Yes, of course. To break down the bonding, HH single bond and then OO double bond, and then they will become separate hydrogen and oxygen atoms. And then after you form this atom which is highly unstable, what will happen next? To form water, okay, some covalent bond they will rearrange and then they will form back OH bond, and finally they combine to become two water molecules. Is what actually happened in the reaction. So again, if I draw it in the diagram, in the enthalpy level diagram, we can add something more to illustrate the whole process. Well, originally, it is hydrogen gas and oxygen gas. Well, and then finally they will become two water molecule. But what will happen at the beginning? You will need some energy to break down the bonding. It means that you are applying energy into the system in order to break this bonding. So if I really draw a profile of it, the energy profile, it will go uphill. And then to this state, we call it transition state, which is a highly unstable imaginary state which consists of only hydrogen atom and oxygen atom. And what will happen after it reaches transition state? As it will form back some bonding, and during the bond breaking it need to absorb energy, and on the contrary, if bond is formed, then some energy will be released. Well, then you may ask why this reaction between hydrogen and oxygen it is exothermic. It means that in the process it will release some heat. Why? How can you compare this energy need to break the bonding and this part of energy released when form the bonding? Which one is higher in value? Yes, the one after the formation of bonding, it will release more energy than the energy need to break down the bonding in the reactant, and will lead to an exothermic reaction. And more precisely, the energy in this case needed to break down hydrogen bonding, hydrogen single bond and OO double bond, is smaller than the energy released when bond forming. So that the overall result is that some energy will be released to the surrounding. Well, and let's see what will happen in an endothermic reaction, say for example cracking. And again, give me some time to draw the axis. Well, let me use an example of cracking of propane, C3H8. and then to become C2H4 and CH4 as an example. What happened in this case? So it is endothermic. It means that you have to apply energy to the system. Then C3H8, we have a lower energy level than the product. What happened in this case? We go uphill and then go downhill. How can you compare the energy emitted? Yes, in this case, the energy needed to break down the bonding in the reactant is larger than the energy released when forming the bonding in the product. So that it leads to an endothermic reaction. It means that it needs to absorb energy in order for the reaction to go to the product side. And more precisely, energy needed to break one CC single bond and one CH double bond is larger than the energy released when forming back a CC double bond from a CC single bond and another CH bond. And if you have no idea, just draw out the structure of these three species and then you will know.